First of all, talking about the dot structure. Dot structure is also known as electronic structure because here we are taking the electrons of the outer shell. Now how will be designing a structure? For example, we are having compound that is molecule that is CH4. There is a theme. Now CH4 will be, C is basically a central atom and H4 is the surrounding atom. First of all, you have to identify that which is central atom and which is surrounding atom. Now C is basically a central atom, then H4 is a surrounding atom. Now designing a structure, first of all, first step was taking a central atom, that is carbon. Taken carbon. Second step, surrounding atom. There are 4 surrounding atom. Hydrogen that will be drawing in the surrounding, that will be surrounding, and that will be a central atom. Hydrogen. Design. Third step is valence electron of each atom present in a molecule. Now will be taking a valence electron. Hydrogen have 1 valence electron, 1, also have 1 and 1. Now carbon have 4 valence electron. How? It has 6, total 6 electron, 2 in shell, in outer shell it have 6 electron, 4 electron, so it will be having 4 valence electron. It will be having 4 electron. Now this whole will be called as a dot or electronic structure. Till here it will be called as a dot or electronic structure. Now the second step, that is solid line structure. Solid line structure is also known as a graphic structure. Either we can say graphic or solid line, both are same. Now Hall will be forming a structure. That was a carbon and that was hydrogen. Now they'll be making bond, hydrogen with carbon, hydrogen with carbon, hydrogen with carbon, and here hydrogen with carbon. Now they have made a solid line structure. As they will be making a bond, so they will make a solid line structure. That structure is known as the solid line structure. Now what will be the third structure? We have made the dot structure, then we have made the line structure. Now these structure means half structure are made. Now we'll be going towards the third structure, that will be hybrid orbital structure. Here the geometry completes. Hybrid orbital structure. Now the hybrid orbitals, there in carbon there are 4 electrons. So carbon basically have 4 electrons. Each electron will be having sp3, sp3, sp3 and sp3. Now how can we know that there will be sp3 hybrid orbital in carbon? In carbon there are 6 electrons, 2 in the first shell, and in outer shell there are 4 electrons. one electron, second electron, third electron, and fourth electron. First one will be having S, second will be having Px, third will be Py, fourth will be Pz. So one S orbital, one S subshell, and then Px, Py, Vz, three orbitals. It will be P3. So sp3, that is why the carbon is sp3 hybrid orbital. We can easily know about the hybrid orbital by these, that it is having 4 electrons, so 1 s and 3 rest are px, py and pz, so it will be having sp3. Now there are total 4 sp3. The total 4 sp3. It is having 1 sp3, 1 sp3, 1 sp3, 1 sp3. And how many orbital, how can we identify that in which hydrogen is having one valence electron? So there will be one electron, that will be s. So it is making a bond only with s. It is having s subshell, and it is having s subshell. So there are 4 s and 4 sp3. Now how will be shaping these sp3, that are 4. Now sp3 are p plus p plus p. We can write it like this. 1, first of all, s, the shape of s will be this. Then it is horizontal, longitudinal, that will be positive and negative, because we know in orbital there is one clockwise direction, second is anti-clockwise direction. So that will be the shape of this. Second py will be this. Then pz will be the shape of pz will be. Now these are actually the shape. Now what will be the final shape of these all together? There will be one big positive side. Negative side means there will be overlapping between them. So overlapping will be more in positive, and negative will be this. So that will be the final shape of sp3. Now making a hybrid orbital structure, we know there are 4 sp3, means that is only sp3, means 1 sp3. We have to make 4 sp3. That is a central atom. Now first structure of 1 sp3, second sp3, third sp3, fourth sp3. First of all, making first sp3, that will be this. 1 sp3 is completed. It is 1 sp3. Now second, that will be second sp3. Now third, this will be the third sp3. Now fourth will be this sp3. That is actually the negative sides, and that are actually the positive sides. That will be 1 sp3. Now there are 4 sp3 and each carry 1 electrons. As I have discussed, they all carry, in every 1 electron there are sp3 hybrid orbitals. They have electron in their corners. Now there were 4 hydrogen and having the s subshell. They actually attach with this electron s got 4. Basically sometimes these s subshell do not mention, many scientists means many people do not mention, because s have a higher energy level and higher energy level does not show their shape. So that is why they do not make any shape, the geometry, only the hybrid orbitals that have a lower energy level, so these will be only making a geometry. Now there will be, their corner will be mixing with each other. This corner joins with this corner and this corner joins. Now they are making the shape that is this one, 4 corner shape. This shape is known as regular tetrahedral orbital. Now this is actually an tetrahedral orbital will be having the angle, a constant angle, that is 109.25 degree. That will be the angle of tetrahedral shape. So that is the final geometry of CH3.